So in this video we're going to solve a linear system in 3 variables for which there are infinitely many solutions instead of that single unique solution like we saw in the last example. So here's the system, and what we're going to do is the same thing we've been doing. We'll put it into matrix form. So we need to grab the leading coefficients and the constant terms. So we get 1, -1, 1, and 3. For the first equation. The second equation, the coefficients are 2, -1, 4, and 7. And for the third equation, we have coefficients 3, -5, -1, and the constant term is 7. So we get the augmented matrix. We then need to put that augmented matrix into reduced row echelon form. We see that row 1 conveniently already has a leading 1. So we need to zero out the entries underneath it. So it looks like we need to do -2 times row 1 plus row 2 to get a 0 in this position. So we're going to be tweaking this matrix. Row 1 isn't going to change. We're making no modifications to row 1. So we get -2 times 1 is -2 plus 2 is 0. -2 times -1 is 2 plus -1 is 1. -2 times 1 is -2 plus 4 is 2. -2 times 3 is -6 plus 7 is 1. So there we've modified our row 2. And now we need to get a 0 in this position. So it looks like we need to take -3 times row 1, add it to row 3, and replace row 3 with the result. So we get -3 times 1 is -3 plus 3 is 0. -3 times -1 is 3. Plus -5 is -2. -3 times 1 is -3. Plus -1 is -4. And -3 times 3 is -9. Plus 7 is -2. So now we've zeroed out everything in the column below this leading 1. Now we step over, we need a leading 1 in this position. We see that we already have it. Now we need to get zeros everywhere else in that column. So it looks like we need to add row 2 to row 1 and replace row 1 with the result. So we're going to go row 2 plus row 1, replacing row 1 with the result. We know the first column isn't going to change, and we're making no modifications to row 2 right now. So we'll just pencil in the stuff that isn't going to change. So row 2 plus row 1 is going to be 1 plus -1 is 0, which is why we did it. 2 plus 1 is 3, and 1 plus 3 is 4. And now we need to modify our row 3 so that we have a 0 in this position right here. So it looks like we'll need to do 2 times row 2 plus row 3, and then replace row 3 with the result. So 2 times 1 is 2 plus -2 is 0. 2 times 2 is 4 plus -4 is 0. And we have 2 times 1 is 2 plus -2 is 0. And what we see is that row 3 is zeroed out. So we're currently in reduced row echelon form right now because each row that has a non-zero entry has a leading 1. And our row with all zeros has been moved down to the bottom. And then we just need to remember that these rows correspond to our variables, x sub 1 column, x sub 2, and x sub 3 columns, and then our constants are sitting here. So we interpret the matrix this way. This is 1 x sub 1 plus no x sub 2's plus 3 x sub 3's plus 3 x sub 3's. And this is the augmented part of the matrix. So everything on the far right is our constant term. So this equals a 4. And then the second row right here, we get 1 x sub 2 plus 2 x sub 3's equals the constant of 1. And we don't get anything from row 3 because it's all zeros. And then what you want to do is identify if a variable shows up more than once. So the x sub 3 shows up twice. So solve for each of the other 2 variables in terms of the variable x sub 3. So this one right here will we'll subtract 3x sub 3 from both sides. So this will give us x sub 1 equals 4 minus 3x sub 3. And this one will subtract 2x sub 3 from both sides, so we'll get x sub 2 equals 1 minus 2x sub 3. And then what we do is parameterize these. So we'll take the common variable and we'll say let x sub 3 equal r, where r is any real number you want, any real number on the real number line. And then we rewrite x sub 1 and x sub 2 in terms of that parameterization. So we get x sub 1 is going to be equal to 4 minus 3 times x sub 3, but we just let x sub 3 equal r. So it's 3 times r. X sub 2 equals 1 minus 2x sub 3, 1 minus 2x sub 3, but we just said, hey, x sub 3 is r. Let x sub 3 be represented by r. And we did x sub 3 equals r already. So as an ordered 3 tuple, if we have the ordered triple x sub 1, x sub 2, x sub 3, what we see is that we've parameterized this ordered triple in terms of a single variable r. So x sub 1 is 4 minus 3r, x sub 2 is 1 minus 2r, and x sub 3 is just r, where r is any real number that you wish.